MG said that he wanted to start with some of the problems in 5.3. So let me pull that up.
Okay.
Here we go. I don't know why it's doing that. There we go.
We don't need to know this stuff, right? Like this is like chemistry stuff, which I learned
no,
last year,
so.
but I do not remember half of this stuff.
Yeah, I don't think this is important.
Okay.
Hopefully. I mean, we learned about the primary and secondary cell stuff,
Yeah.
but it's not really relevant for the problems. So unless there's going to be like theoretical problems. Is this one of the, no, this isn't one of the questions, right?
I think they're towards the end, but I'm not sure.
This one?
No, I think they're towards the very end. Like if you go scroll all the way down.
Oh, these two.
Yes.
Okay. The cell has an unloaded voltage of 1.6 volts and a loaded voltage of 1.5 volts when a 330 ohms resistor is connected as shown. I feel like there's a lot of steps here. Okay. So the first thing was to find the electromotive force. Okay, so that's just the same as the unloaded voltage, right?
So the unloaded voltage is, but that's terminal voltage, right?
Mm-hmm.
So I'm a little, so is the internal resistance negligible then?
No, wouldn't that,
Because actually, V equals big, or I parentheses big R plus little r, because that's like the net, I guess, net resistance, right?
Right.
So how do we get where did we get the 1.6 volts from?
I don't know. I honestly don't know how that works either.
Okay, I think a good rule of thumb, because this is too soon till the test, I'll ask her something. I'll text her and I'll ask her if we don't get a response. Then I guess kind of the rule of thumb is if it's unloaded, the terminal voltage is the electromotive force. That's I guess the rule I'm seeing from here.
So does unloaded mean like no resistors other than internal resistance, like not including that?
Yeah, I mean that's what I think. I think it's the unloaded. See, but then there's still internal resistance though, right? How do you reconcile for that? Like how do you compensate for that?
Wait, can you explain why unloaded voltage is going to be your electromotive force?
That's what I don't understand. I think that was my problem.
Okay.
I looked up what an unloaded circuit is. Because, for example, if the lamp is connected to the circuit, but a direct connection is present between the battery's negative terminal and its positive terminal too. So it's also called a short circuit.
Okay. Okay, so I guess it's a short circuit. So I guess an unloaded circuit or short circuit, whatever it is, I guess what that's saying is essentially it just flows through without any resistance.
Yeah.
So we're assuming the resistance to be zero because we're calling it an unloaded voltage, like altogether, like no resistance period. Okay, I guess
I guess that would be fine, because if you look at this equation, like the internal resistance is included inside the electromotive force. So then it might work, like mathematically, like it makes more sense.
Okay. Okay, so electromotive force is 1.6. Current would be, you would use the second one for the current, right?
Yeah.
So current would be V, terminal voltage, which is 1.5, on R. Big R is your, what is it, 330? Mm-hmm. And that's where you get I know the answer's on there, but I just want to confirm. 330.
We need V and R to find I, so you would have to use the second one.
C. Okay, so now we say electromotive force equals I times big R plus little r. I guess that makes sense. Okay.
That
Yeah,
that's
that
one
makes
was
sense.
part of this problem, honestly. Okay. And then, so the third part was find the cell's internal resistance. Okay. I mean, we just plug stuff in, right? So that's not too
Yeah.
complicated.
Okay.
I didn't understand this part at all. What is the terminal potential difference TBD of this? Is it supposed to be TPD?
Yeah, I think TPD is terminal potential difference.
Okay.
Yeah.
Let's see.
So then that is V equals big I little r, right? That would be terminal potential difference or terminal voltage, right?
Right. Yeah. That would make sense. Yeah. I don't think it has the answer here though.
It says loaded terminal potential difference of 1.5. Oh, terminal potential difference depends on the load. Okay, I guess that makes sense.
So is that just how much, like the potential difference across like the whatever, like?
Yeah, across the battery in parallel. Yeah.
Okay.
Oh, this is another important rule I remembered. That the voltmeter needs to be in parallel with the cell and the ammeter needs to be in series with the cell, right?
Yeah. But if it's an ammeter, then it's like it can only be in series with whatever you're measuring, unless the circuit is the same throughout, unless the current is the same like throughout the whole circuit.
Okay.
Okay. Should we go to the next one?
Sure.
Okay. When a dry cell is connected to a circuit with a load resistor of 4 ohms, there is a terminal voltage of 1.3 volts. When the load resistor is changed to 12 ohms, the terminal voltage is found to be 1.45 volts. Okay, so the first thing is the EMF. So we would use the same, like this one, right?
Yeah. The terminal voltage equals electromotive force minus big I little r. Okay, I'm kind of confused overall about this.
But we don't know what little r is, do we? I mean,
Oh, you have a system of equations, I guess.
See. Okay, yeah.
Oh gosh. Okay, I see.
I hate when they pull in like systems of equations like quadratics into physics. It just makes everything so much more confusing.
Dry cell is connected to a circuit. Do you have the 5.2 PowerPoint?
Yeah.
I feel like if we look at that slide where it talks about terminal voltage, that would, because I feel like I don't have a clear understanding of that.
Yeah.
Like I kind of get it, but not really.
Terminal voltage, the way I understood it was like taking away, here it is. Right. It was the actual voltage delivered to the cell, and it's less because of the internal resistance. So that takes away some of the actual voltage.
Are you sharing? I don't think you're sharing that one. I think you're still on the other PowerPoint. Yeah.
Okay. Here we go.
Okay, I got that part. So yeah, I agree with, I think that makes sense what you were saying.
So the terminal voltage is the effective resistance, or the electromotive force over the effective resistance.
Can you say that again?
The terminal voltage is the electromotive force over the effective resistance, then, right?
No, it wouldn't be over anything. You're just subtracting.
I'm thinking of the current through the cell. Never mind. I don't know why.
Oh, I see what you're saying, Maham. You're saying current. Yeah. Okay.
Yeah, I was thinking of the
Okay, so that means electromotive force is equal to big I big R plus, or big I times R equivalent plus big I times the internal resistance, right?
Yeah, and then big I, the big I big R is equal to V. So that's where we get the
Oh,
equals.
okay, I see. So we used Kirchhoff's
Right. So that's where we
rule.
got this from.
I see. Okay, that makes more sense now.
Wait, so just to be clear, the internal resistance is just the resistance that comes from the material, right? So like
Yeah.
the lattice ions within the whatever it's flowing through, and then there's actual resistors that can be added to the circuit. Okay.
Yeah.
Okay, so what did they do here? So they used the first circuit, right?
Right. So first they find the current for each, and then they plug the current into this equation. And so basically there's two unknowns, right? There's electromotive force and there's little r. And so I guess they said both of them equivalent to electromotive force, and they found r.
Oh, okay.
And you plug it back in and you find EMF.
Got it. Okay.
Can you
So
guys
the
point
EMF and the r is the same for both these equations, right?
Internal resistance should be the same, right? Like you were saying?
Yeah.
Because it's the same cell. So if you have the same cell, same internal resistance. Okay, that makes sense.
can you guys explain just quickly like the definition, like what electromotive force is? Because I'm a little like muggy on the definition.
I think it's the potential difference created by the cell. Like it's not a force, but it's the potential difference which is acting as a pushing force of current, I guess. Yeah, that's kind of how I think of it.
Well,
I don't know if that's accurate.
I don't like a technical definition, and I don't mean power the way that we like learned about it, but I mean it's basically like how much power the cell has. Like not power as in like the physics definition, but it's just like how much power this, like how much can it give, how much energy can it give.
Like a pushing power force. That's kind of how I think of it. Once again, it's not a force. It's terrible. I hate that I have to think of it that way, but I don't know, that helps me for some reason.
Okay, so that's both of these. The other ones that we can go over is the ones that we had the Ohm's law problems. There were a lot of those. I remember 51 was really confusing. It was the one about like there were like so many resistors in parallel, and we had to like simplify it down.
51, like which one?
It's from the Ohm's law one. Actually, let me just share my screen.
Oh, I remember. So the way those are like logic puzzles. Like you have to like start small, get bigger, and then fill this in, and then fill it. Yeah, they're actually kind of interesting.
I did it differently than the way that they did it. I feel like the way they did it was actually like it was really. I mean, for me, it was really hard. I did it like a way that I thought was easier, and in the arithmetic part, not in like the physics. They're also in the physics respect, but like arithmetic wise.
It was just honestly, I started solving it and then I realized it would take way too long because I thought these problems were going to be due a lot sooner than they actually were. So I just kind of skipped it. But yeah, we can, I don't have the answer key.
You have the annotate feature, and then we can kind of work through it, I think.
Yeah, I can do that. Let me just, I just wanted to pull up the answer key so we can.
Sure.
I think it's like, it got deleted in the Slack history. MG, do you still have the link?
Oh, I don't know. It's okay. I think I know how to do this. So, like, if you work through it, we can always.
I remember the answer is 8.
Okay.
Yeah.
Okay, let's just work through it, and then of course we can I'm sure we'll figure out if it's right or wrong.
Okay. Let's see. So we just have to start simplifying these down, right?
Mm-hmm.
Okay. So for these two, it would be. Oh wow, that's not what I wanted. So it would be 1 over 24 plus 1 over r, right?
Yep. But then you have to take 1 over that, right?
Yeah. How would you? Oh, okay.
So that's actually how I write. So that's actually how I write the formula. Whenever I do the problems, I don't know if you guys do this, but I actually write it as 1 over. Sorry, that was a really long line. 1 over a plus 1 over b. I don't actually do the 1 over r equals 1 over r1 plus 1 over r2. I just write it like this, and that equals r.
Yeah, no, I usually do it this way.
For the 24 over r for that one, you like specifically like, I don't know if there's any other way to do besides like doing the 1 over 24, because I put it all inside. You can just do it your way, and then I'll tell you how I did it.
Okay, and then the way that I like multiply this out, I multiplied this by r over r and this by 24 over 24, and then so on. So then that would be equal to, so r and 24. So 24 plus r. You know what? I think if I type this, it'll be easier.
Sure.
Okay. So it would be equal to 24 plus r over 24r, right? If we multiply that. And then you would flip it. So it would be 24r over 24 plus r.
Yep.
Okay. So let's do this away. So, okay, the next one is 4, but we just add that, right?
Yeah.
So right now there's 24r over 24 plus r. And then if you just add 4, then just add to the top, right? So it'd be just 24r plus 4.
But we need to take the common denominator again, right? Because our common denominator is 24 plus r. So we need to multiply 4 by 24 plus r. Here, what's 4 times 24? 24 times 4 is 96. So then you would add the 96 to the 24 because that's like terms. And that would be 120r in the numerator, really.
In the numerator, okay.
120r in the new plus, sorry, 120r plus the 4, right? Because.
Right, yeah. But wait, okay, but how can we can't have the 4 have this.
Oh, wait, I'm sorry. 120 plus 4r. I'm so sorry. What did actually no. I probably did this whole thing wrong. Okay, yeah, I need to write this out.
Okay, we can multiply the 4 times 24 plus r over 24 plus r.
Okay, so it'll be 96 plus 28r on the top, right? Because 4 times 24 is 96, right. And then 4 times r is 4, so 4r, and then you add 4r to 24r, so you get 28r.
Wait.
So this is after you add that to 4.
Oh, after you, hold on. So we're multiplying the 4 by 24 plus r over 24 plus r, right?
Yeah, to get a common denominator.
Right. So wouldn't you get 96 plus 4r for the numerator?
Yeah, 96 plus 4r, and then you add that to the 24r because it's like
so terms. 96 plus 28r.
Yes. So it would have 96 plus 28r on the numerator.
96. Okay. And then, so these two would just be 4, right? Because you just add them. And then, sorry, these two, 1 and 3, those two would just be 4 because they're in series.
Yeah.
And then you would you flip this again, and then you add it to 1 over 4, yes.
Yeah.
So let me flip this. So 24 plus r over 96 plus 8r plus 1/4. How do you even you would have to multiply it by 96 plus 28r for both for the 1 and the 4.
The 96 plus 28r is divisible by 4, right? So you could probably just take 4 and then Yeah, you could take the 4, the 1/4, and multiply by the greatest common factor. Wait,
What?
sorry, can I let here? So you're adding that to 1/4, right? So
Yeah.
4 times what is 96? 4 times 24 is 96. And then 4 times 7r is 28r. So I'm multiplying the top and the bottom by 24 plus 7r. So now you get a common denominator.
Okay. And then we would do 24 plus 7r plus the 24 plus. Okay, so you would end up getting 48 plus 8r on the top.
Yeah, we would get a 48 plus 8r on the top and 96 plus 28r on the bottom, right?
Yeah.
Oh my gosh.
48 plus 8r. Okay, so that's the total resistance. We should probably
Yeah.
simplify that. Can it be simplified? Yeah, we can divide everything by 2, right?
Yeah. Yeah, we can do that.
And by 4.
Or
Whereas
yeah,
it
we could
makes
divide
sense.
everything by 4. Mhm.
Yeah, okay, so
12 plus 2r on.
12 plus 2r.
Yep.
12 plus 2r over what?
24 plus 7r. Yeah.
So, okay. Oh my god. It went away.
You can hit Control Z. It should work. It should come back if you hit Control Z.
Okay, cool.
So now.
Let me just leave it. It's not letting me erase just this.
Okay. Then.
Um,
Oh, V equals IR using Ohm's law. So that means R equals V over I.
yeah.
Yeah. So V over
So
I.
100 over 35. So it equals about 2.8.
Yep. So now we have to just solve for R, right?
Yes.
Oh my gosh.
That'll take a minute.
Yeah. So then you cross multiply 35 times 12 is 420. Oh, well, it depends if you want to cross multiply or not. That depends on whether you treat it as a fraction.
Wait, could we cross multiply? Like if we set it up as 100 over 35?
Yeah, that's what I did. I like to deal with the fractions first and then only round at the end, because otherwise all sorts of weird things happen.
That would definitely be a lot easier.
I'm gonna get a negative answer, and that doesn't seem right. That means we we might have done something wrong.
Okay, let me finish and see what I got.
Sure.
Yeah, I think I'm also going to get a negative answer.
We got about negative pi, negative 3.14, but then it's 2/8. So while it's a cool answer, I don't think that would be right.
Yeah. Okay.
Oh gosh.
Yeah, I got the same thing. Negative 3.14. Actually, that's almost exactly pi.
Yeah.
Wait, for this, you got negative 3.14?
That's not correct. We know that's not correct. That can't be correct.
I know. I like it was really, really difficult. If you want, maybe I can try.
So here, let's just do it really quick one time. So it would be 1 over r plus 1 over 24. That's this bit right here, right? That's that bit there.
Yeah.
And then if you add that to 4, that's this bit here. And then we need to take 1 over all of that and then add that to 1 over 4, right?
Yeah.
And then that will equal the what was it?
20 over 7.
Equals IR, so R equals V over I, 100 over 35, right?
Yeah. 20 over 7.
Oh my gosh. So that would become a 24 like we did. That's an R. That's an R. So 24 plus R. So this portion would become what? 24R over,
Over 24 plus R.
I think that's what we did, right?
Yeah, that's what we did.
And then you flip that again to get, 24 plus R on 24R. And then you add that to, oh, wait. Did we add that to the 4 here?
Yeah, the 4 is supposed to be it's supposed to be right here.
Or you could
Here?
wait, which 4? Oh,
No,
you're
but that's not.
Oh, that's just normal 4, right?
Yeah,
Sorry.
that's regular, not 1 4.
Oh, God. Okay. That's plus 4. Okay, so we've got this part done, right? This part is done, and that part is here. Yes,
Yes.
that's done.
Yeah.
So now you add 4. So if you add 4, that means you need a common denominator of 24R. So you multiply by 6R.
Yeah.
Are you the 1/4 plus the entire thing right now?
Sorry?
Are you adding the 1/4? So you know how it's 1/4 plus 1 over the whole thing? Are you
Yeah.
adding that 1/4? Because you can just subtract that from the other side, can't you? Because if it's 20 over 7, then 1/4 comes out to be 6 over, wait, no. Because earlier when I was doing it, it simplified out really nicely because I kept flipping them over and over again, and then mine simplified out really, really nicely. Which is why I'm trying to figure out like how I can make that. But it's okay, you can keep doing what you were doing.
Okay,
Oh,
so
yeah, this 1/4 you're saying you can, yeah, we can do that at the end. So now you would add these two, right?
Right now, okay.
Oh, okay. You would get 97R plus 24 divided by 24R. Now that's all this bit, and now you flip that. So now you get 24R
oh my gosh.
on 97R plus 24.
That's 24. Mhm.
Okay. And then you add 1/4 to that. To be quite honest, at this point, I would break this fraction up. I would say that's 24 over 97 plus R, right? Because 24 over R over 97R. Wait, no, we can't do that. I don't know what I was thinking. That's a bad idea. Do not do that.
Okay.
Pat, I don't know what I was doing. Don't do that.
I think before what we did for the 1/4 is this right here. That's
okay.
the first time we did it.
So something went wrong the first time. Somehow we got a 90. So I think we should do what Maham said. So move the 1/4 over now. So now put that in your calculator because I'm too lazy to try and do this out by hand at this point. Minus 1/4.
It's about 2.6.
Okay. So now we can multiply that by, this is the 2.6 number, right?
If we want a fraction, it's 73 over 28. That might be easier.
Yeah. At this point, I'm willing to work with anything just to get the answer. So now multiply that by 97. That means 24R equals 2.6 times 97, which is the 252.9. 9R, and then 2.6 times 24 is 62.6.
I'm still getting a negative.
We're still gonna get a negative answer.
Yeah.
Oh my gosh, this is so frustrating.
Let me try because
Okay, go ahead.
I got this right like, literally an hour ago. Okay, so maybe with my luck I'll do it again. Okay.
All right.
So let me annotate real quickly, but I'm using a MacBook, so that's gonna suck. Okay, so
we got a negative answer, but it was different from last time. So we did something differently, but
yeah. So the way that I did it was it might be weird to you guys. I don't know, but I'll just show you. Okay, so frick, where's the annotate?
Wait,
feature?
why don't we find the current first? I don't know. Sorry, Moham, you do it first. Sorry. Yeah.
Okay. So so the way that I did it was 100 over 35, so that gives you 20 over 7, right? And then we have that we set that equal to, so the way that I think I went about it was basically I did four. Well, first I did like 4 over 4 plus or no, sorry, I'm not gonna do this part yet. Okay. So it was really long the way I did it. Okay, 4 plus 1 over 1 over 24 plus 1 over r, and then that whole thing over, or yeah, that whole thing, yeah, so 1/4. So yeah, that this entire thing plus 1 over 4, right? And so it's yeah, so 1 over 4. Oh my gosh, I'm so sorry. I get always freaked out whenever I do this. How do I erase this?
It's hard to do it on the laptop, especially.
Okay, can I just say what I did?
Yeah,
That
yeah,
way,
that's fine. That's fine.
I'll just say it. This is gonna take us the rest of our lives. Okay, so what I did was, okay, Lord help me. Is this 51? Okay, here we go. All right, I got it. All right, so 20 over 7. I did 1/4 plus 1 over 4 plus, and then parentheses 1 over 1 over 24 plus 1 over r. And it looks really bad right now, but I'll break it down, right?
Mhm.
Then what I did was I just right off the back subtracted the 1/4, and then okay, yeah, so here's what I did. So then I basically flipped it. Just right off the bat, I flipped it. So what ended up happening is I had 7 over 20 is equal to 1/4 plus 1 over 4 plus 1 over 1 over 24 plus 1 over r, right? Then I subtracted 1/4 from both sides. So 1/4 simplifies out to 5 over 20. But it's 7 over 20 minus 5 over 20, which gave me 2 over 20, which is 1/10. 1/10 is equal to 1 over 4 plus 1 over 1 over 24 plus 1 over r. Then I did what did I do? Oh yeah, then I flipped it again. And then I had 10 is equal to 4 plus 1 over 1 over 24 plus 1 over r. Then I did 10 minus 4, which is 6. Then I had 6 is equal to 1 over 1 over 24 plus 1 over r. Then I flipped it again. 1/6 is equal to 1 over 24 plus 1 over r. Then I solved for r and I got 8. Because 3 over 24 is equal to 1 over r. So that 1 over r,
Okay.
or r is equal to 8.
Honestly,
I
you
just kept
lost
flipping
me,
it over.
but I got the last part. But if you could you send a picture of your work on the Slack maybe? I think
That would help you. Also, I just realized you could do this using current. That might make it easier, right? Because Maham, could you clear? Yeah.
Oh yeah. Oh yeah.
And then sorry, I hate taking up so much time on this one problem, but so if it's 35, right, and it's gonna go through these two, then you know that the current going through here plus the current going through here must add up to 35, right?
Right.
So 35 equals I1 plus I2. Now the total resistance going through here is 4 ohms, and I equals V over R, right? So if we know the potential difference is 100 because it's in parallel, we know it'll be the same. Since it's 100, resistance going through this circuit or this line is 4. This series, I mean to say 4. So current going through I2, if this is I2, the bottom one is I2, that's 25. So that means I1 must be 10, right? So if this current is 10, that means the current going through here is also 10, and then it splits. That means 10 equals I1 going through here plus I2 going through here. Well, I1 we can figure out because we know that I1.
That's definitely much easier than what we were trying to do.
Yeah. So I1 equals V. We're gonna have to break up the potential again. We might.
I think the answer key actually it did it the same way that we were trying to like simplify all the resistors. I think it did it that way.
I would not do that.
Yeah.
So the R here is 24. The potential. What's the potential difference across the 24 ohm resistor? How do we find that? Oh, well, we know it's 100 going through. So V here equals IR. I was 25. R was 4. So is it up? No, that can't be right. V equals IR. Oh, I1 was 10, right?
10,
this
yeah.
is 10 times 4, which is what, 40?
40, yeah.
That means potential difference here is 60, right? PD equals 60.
60, how?
Oh, because the potential difference across the top must be 100, right? Because the terminal voltage is 100, and since it's in parallel.
Oh yeah. Wait, the voltage stays the same for both, right? Like there's 100 going through this branch, and there's also 100 going through this branch.
Yes, but because it's broken up, there's another. The voltage here is not the same as the voltage here, because.
Yeah.
Okay. I just wanted to clarify that. Okay, so we have 60 potential difference here, so that means we have 60 V. So 60 over 24 is the current going through I1 on this I1. So 60 over 24 is what?
It's 2.5.
Yes, 2.5. So we said that I1 plus I2 is 10. So I2 here is going to be 10 minus 2.5. 10 minus 2.5 is 7.5. That means 7.5 is the current going through R. I might be wrong. Can someone double check that in the answer key if they have it? That means R equals. Yes. Okay, good. That means R equals V over I. So V was we found, right?
60.
That was 60. Good.
Yeah.
60 divided by 7.5, and what do we get when we do that?
And we got 8.
8. There we go, Maham. We got the same answer. This is much easier.
I know you.
Oh my gosh. This is so much easier.
We actually just spent like half an hour on that.
You know, I feel like if you can do a complicated circuit like this, you can probably do the easier ones. So I think it was worth the time. That's my personal opinion.
No, that was good because I had to quit that the first time. I was not able to do that by myself. Okay. Are there any other problems that we want to go over, or should we just end for today?
Well, I'm pretty comfortable with the terminal voltage now. So because I think all I have to remember is electromotive force equals big R plus big I little r, because it's the total current. Yeah, that's if I remember that, then I think I should be good. Yeah, I should be good if I remember that.
And I made this I always make index cards for the test, so I'll send it on the Slack. It's mostly just the equations with a few definitions as well. So.
Okay.
I do that too. Oh, that's not very cute.
Okay, so just to make sure we have everything down, power equals IV, current equals V over R. That's Ohm's law. Or really Ohm's law is that given constant resistance, current is proportional to voltage. What else do we have?
I have a question. Okay. So electromotive force is equal to the current times the effective resistance plus current plus or current times the internal resistance, right?
Yeah.
And then what's it called? The other formula for is also that terminal voltage is equal to electromotive force minus internal resistance times current, right?
Yeah.
So is that I'm trying to find the correlation between the two.
Because in your first one,
because V is equal to IR, so they just replaced it in one of them.
Oh, I see. So okay. Because terminal voltage is just the voltage when it's going through the entirety of the circuit, right?
Yeah.
Okay.
Yeah. Because
Okay,
V and
okay.
I are always interchangeable, so you can always replace one for the other.
Okay.
Got it.
And then in series, voltage is the same, but current isn't. In parallel, I meant to say. In parallel, the voltage is the same, but current isn't. And then in a series, current is the same because it's going in a line, but the potential drops because it's using.
Hold on. In parallel, voltage isn't split, right? So if there's if the EMF is 100, then each of the branches are going to have 100. It's not going to be like
given
50.
internal resistance is 0.
Okay.
Right.
Yeah.
Okay,
Wait,
I think I'm good.
good.
I think I'm good.
I have one more thing, I promise. So if current is equal to, remember how I was saying this earlier, how current is equal to electromotive force over the effective resistance, right? So if that is the case, then but V is equal to IR, and then in this case, the V is equal to terminal voltage, right? Then why is current why is current the electromotive force over the effective resistance and not the terminal voltage over the effective resistance?
Generally, current is V over R. It's just we assume internal resistance is 0. So most of the time we work with 0 internal resistance. So sometimes I equals
And then they say that the EMF is equal to the voltage if we're assuming that the internal resistance is 0.
Okay, I see. That makes sense.
I was a little bit confused by potential dividers, but I feel like that's just saying that's just like another form of a circuit, and you can just use the same laws and the same rules to solve it, right?
I think so. That one was confusing for me as well. I still need to go over that.
Okay.
Because I studied for the test like a while ago.
Yeah. Okay. I think I'm good.
Okay, this was great, guys. Thank you guys for coming.
Thank you. This was very helpful.
You.